Okay, hello everyone. My name is Yuan. I come from Jilin University. My report title is Multi-Objective Ecological Strategy Optimization for Two-Stage Disassembly Line Benching with Constrained Resource. The contents of the file path: introduction, establishing model, algorithm design, experimental results and analysis. Finally, the conclusions. The first introduction have the development need and the policy support. In the first part, remanufacturing can reduce resource use and environmental impact throughout a product life cycle. It is simply an essential part and can promote the reuse of resources and reduce the environmental impact of products. The disassembly of obsolete products has become an urgent problem to be solved. Disassembly plays an important role in a green manufacturing system and full statement cycle evaluation. For the policy support, the recycling and remanufacturing of waste products have been included in the strategic emerging industry. In recent years, China has also issued relevant policies to promote the recycling of waste agricultural machinery products. The Ministry of Agriculture and the Ministry of Agriculture and Rural Affairs put the policies. The implementing of the above policies will help promote the transformation and upgrading of agricultural mechanization and green development of agriculture. For significance, the development of modern agriculture is the primary task of implementing of rural revitalization. The circular agriculture model is the frontier of the development of modern agriculture. One of the main connotations of the development of circular agriculture is to utilization of agricultural waste resource. Its application not only had a guiding significance for the disassembly analysis, but also provides a basis for disassembly decision making and relevant standard formulations. It also provides decision support for the green disassembly process design. Okay, look at the literature. This contains disassembly assignment and disassembly plan. For disassembly assessment, the paper proposed a comprehensive method for analyzing the disassemblability of products, and the John proposed a multi-level of disassembly evaluation model and method. For disassembly plan, the Conger and Cooper first planned the disassembly sequence with the goal of disassembly time and the changes in the disassembly direction. The team applied the algorithm to realize the selective disassembly sequence plan with the largest disassembly income. Okay, although scholars have discussed the optimization and evaluation of the disassembly sequence of the product and achieved certain research results. The shortcomings are as follows. First, the current research on disassembly magnetics, disassembly efficiency, and economy as indicators. With the focus on resource utilization, it's necessary to introduce new manufacturing disassembly optimization problem. Second, there is a non-linear interactive relationship in the evaluation of the assembly of agricultural machine products. It's necessary to construct an evolution index system and evaluation method for waste agricultural machinery. Okay. This study aims to solve the multi-objective two-stage disassembly line balancing problem with time, economic, energy consumption, and environmental considering. There exist multiple factors that affect the disassembly process. However, energy and environmental factor are the most difficult issues in the disassembly workshops. To solve this problem, this study establishes a multi-objective two-stage disassembly model with resource constraints. Okay, look at the picture. This is the model we established. In the first stage of the disassembly process, mainly contains pre-treatment, performance test, disassembly, crushing, calorie sort, and in the second stage, contains clean evaluation, restoring assembly test, and storage. Okay, under the conditions of mechanical constraints, process constraints, and energy constraints, this also have the same assumptions. One workstations only disassembly one part at a time. Two, the disassembly time of each disassembled component doesn't interfere with the other workstation. And the file, the main consideration is the energy consumption caused by the direction and the movement time of the disassembly. The device starts at the first test and it closes when the last test is completed. Okay, under the conditions of mechanical constraints, process, and energy constraints, the model built with the time, energy consumption, economy, and environment. Function 1 to function 4 as follows. Different from the sequential two-stage production system, we introduced the resource-constrained two-stage DEXIG is not only consumed in the first stage, but is consumed in two stages. LAMP-G represents the initial input of the GSDMU. XIG is allocated in the first stage. LAMP-G XIG represents the input of the GSDMU in the first stage, and one minus LAMP-G XIG represents the partial input of the second stage. Different from the two-stage DM model by Chin, this study used the arithmetic mean and the geometric mean to maximize the efficiency value of each stage and coordinate the overall efficiency of each stage. Now, we introduce the algorithm design. We introduce an ecological strategy, and mixed variation to improve the local search algorithm, and proposes an ecological strategy non-dominating sorting genetic algorithm named NSGA2. It contained 5 steps. Uh, the first step is coding and initialization. Uh, we also use the random number of 0 to 1 for encoding. And two steps calculate the degree of congestion. The density around a given individual in a population is defined as the degree of congestion. The Euclidean distance is calculate the degree of congestion. The three-step ecological evaluation strategy. The ecological strategy is an evolutionary strategy formed by nature creatures. There are uncertain environment changes in disassembly and remanufacturing. So, the ecological evolution strategies can reduce the impact of environmental factors. The first step, mixed variation. Mixed variation is the combination of Gaussian mutation and the Gaussian mutation. It can speed up convergence, while the Gaussian mutation can avoid local optimization. The variation factor is selected based on the relevance of each variation and weights of the optimization goal. This is the function of the Gaussian mutation and the Gaussian mutation. The first step makes the Pareto solution dominance. The Pareto dominance is used to optimally order functions. The image of the Pareto optimal set in the target space is called the Pareto front. It as the follows. Now, we mainly introduce experimental results and analysis. We select time, economy, energy consumption, and environmental as the performance targets. We use the multi-variable input and single output. The data used this study comes from the 9 disassembly enterprises in China. The paired solution of the multi-objective disassembly sequence obtained by NENSGA2 in Table 1. Table 2 shows the input and output variable of the two-stage DEA. Time, economy, and energy consumption in the disassembly stage. There are 5 inputs to the stage 1, which the second stage has 4 inputs and 1 output, which are characterized by the disassembly of energy consumption and the environment. There is also an intermediate matrix between the two stages, namely the PDR. The data are provided in Table 3. Okay. The disassembly efficiency results from the resource constrained to stage DEA model are reported in Table 4. The fifth column shows the overall disassembly efficiency of the obtained models. To illustrate the effectiveness of the two-stage DEA for resource constraints, the model is compared with the chain model. As seen from the figure 3, the efficiency of our model is significantly higher than the efficiency value of chains. From the picture 4 is an area chart of the efficiency ranking. The higher the ranking, the more prominent the area. Okay, now to verify the effectiveness of an NSJ2, the paper introduces 12 typical benchmark functions, including single model functions, multi-model functions, and fixed dimensional multi-modal functions. A table 5 lists the corresponding formulas and descriptions of these functions. Now, the benchmark results and discussions. Table 6 shows the average calculation time of the three algorithms for the instance in the first stage, second stage, and the total calculations. Okay, the performance comparison of algorithms, the average and the standard deviation of our test results in each group of parameters stated are in table 7. The bold type is the best results, indicating that the average error is small. Therefore, to make the comparison effect more obvious, we choose a small scale and large scale for testing. Figure 5 and 6 are the test error graphics for small and larger examples, respectively. To better show the spatial distribution of the Pareto solution, the figure 7 is a three-dimensional spatial diagram, and the figure 7 represents the spatial distribution of Pareto solutions at small, medium, and larger scales. Okay, this part is the conclusions. This study establishes a multi-objective optimization for two-stage disassembly model with resource constraints. The goal is to maximize the overall disassembly efficiency, time, energy, and economic environment based on change model. This study proposes a new two-stage DEA efficiency measurement model. It can effectively rank the assembly sequence. This model is used to evaluate two-stage assembly efficiency, which may be more attractive because it gives a weight for each stage. This study used a simple arithmetic mean to solve the efficiency value of each stage, but instead weighs the two efficiency in different ways to evaluate the proposed algorithm. We compare it with other algorithms. Although the effectiveness of the proposed model and algorithm has been verified. There are still some interesting directions for further research. For example, in the actual production process, it's difficult to know the exact information of the job in advance and uncertain event occur. Therefore, it is necessary to establish new models for multi-objective situations in uncertain environments, design some mathematical optimization algorithms, branch and bound method, a dynamic programming method. The collaborative disassembly workshop scheduled with a digital twin technology. That's all. Thank you.